Welcome students. So in the previous classes we have completed our chapter number 1, that is chemical reaction and chemical equation, and the second chapter, that is acid, base and salt. Now let's moving to the third chapter of the chemistry, that is the metals and non-metals. Okay. So before starting this particular chapter, I want to make you aware about some of the old topics. The first topic which I am going to make you aware is the matter. Okay, so I think so everybody may of you are aware of matter. So what is a matter? How will you define matter? So matter is anything which has mass and can occupy the space, or in other words, it has volume. In other words, we can term that it has volume. So this is termed as matter. So matter, as you know that around us numerous amount of matters are present. Okay, so how to make a proper arrangement or classification of the matter so that we can easily make a study for them. So for that particular purpose, what we have done, we have made the classification for matter on the two bases. Okay, one on the basis of their physical properties and one on the basis of their chemical properties. So the matters can be classified on the two ways, and the first classification way is the physical classification. Okay, the physical classification of matter means the classification of matter which is based on the physical properties of matter. Okay, and the second is the chemical classification of matter, that is based on the chemical properties of the matter. Okay, further if we move here, so physical classification of matter is nothing other than the state of matter. Okay, nothing other than the state of matter, that is solid, liquid and gases. And you know that other classifications are also here, classification of matter. Okay, so here solids, liquids and gases, these are the three classification, major classification of matter. Okay, but other than these two, other than these three, solid, liquid and gases, there are two more physical classification. There can be two more physical classification. One is the plasma, and the other one is the Bose-Einstein Bose-Einstein condensate. Bose-Einstein condensate. Okay, the other one is the Bose-Einstein condensate. Okay, so let's talk about this plasma, Bose and Bose-Einstein condensate. The plasma are the, it is the ionized gases. Okay, it is the ionized gases. Okay, which is produced by passing an electric current through the air. Current through the air. Okay, so what happens when we pass electric current through the air? What will happen there? there the ionization of gases will take place. Okay, what does this ionization of gases means? The ionization of gases means to produce positive or negative species of particles. Okay, when positive or negative species of particles are being present or produced, that particular process is known as ionization. Okay, that particular process is termed as the ionization. So when the gases gets ionized up, they produces plasma there. Okay, so the plasma's example can be the spark, which is seen due to any electric current or any electric short circuit or like that. Okay, or the you have seen the electric arc welding. Okay, welding, electric welding. Okay, so the electric welding, the arc which is produced out there, the spark which is produced out there, that is nothing other than the plasma. That is only the plasma. Okay, the lightning which is occurred during the rain and heavy storms time. Okay, so that is also an example for your plasma. Okay, next is the Bose-Einstein condensate. Bose-Einstein Bose-Einstein condensate. Okay, so what was the Bose-Einstein condensate, which was defined by Bose, Stendra Chandra Bose, and Albert Einstein? Okay, so the Bose-Einstein condensate was an matter. Okay, it is a state of matter which is produced at absolute zero temperature. Absolute zero temperature, or these temperatures are also termed as cryogenic temperature. Okay, these temperatures are also termed as cryogenic temperature. Cryogenic temperature means the temperature that is having very lower range. Okay, that is about minus 27 273 Kelvin. Okay, sorry, minus 273 degrees Celsius, that is equals to 0 Kelvin. Okay, so near about this temperature, when some of the particles or some of the substances are bought, then what happens? They behave something like other. Okay, for example, the superconductors. Superconductor. The superconductors are the substances. Okay, they are the substances when bought near about this absolute zero temperature. Okay, absolute zero temperature. They starts conducting the electrons. Okay, they start to conduct the electricity there without any friction there. Okay, means without any resistance. Okay, no resistance will be there for this type of superconductors. Zero resistance will be provided there. Okay, so similarly, superfluids are also there, which are some of the examples for the Bose-Einstein condensates. Okay, so here superfluids or superconductors are some of the examples for your Bose-Einstein condensate. Okay, which works at absolute zero temperature. So these were the two extra or two matter state of matter which are present as the new states of matter, okay, in the science. Now let's moving back to the solid, liquid and gases. So solids, let's talk about solids. Substances that have very high intermolecular force of attraction. Sorry, not intermolecular, let's take it as interparticular. Okay, okay, force of attraction also that it have very high interparticular force of attraction between their particles. Okay, substances that have very high interparticular force of attraction between their particles, and due to this they have very less interparticular space between them. They have very less interparticular space between them is called solid. So are called solid and are called solids. Okay. What are some of the properties of the solid? So properties of the solids and the properties of the solid. First, they are hard. They are hard. What is the reason for their hardness? Due to high interparticular forces, particular force of attraction. Due to high interparticular force of attraction, the particles are closely packed. Particles are closely packed and and they become rigid. Okay, they become rigid as their shape their shape can't be easily changed. They have fixed shape due to their hardness and due to the fact that their rigidity, they are rigid. They have fixed shape and fixed volume there. Okay, they have fixed shape and fixed volume. Okay, they have high melting and boiling point. High melting and boiling points. They have high densities. Okay, they have high densities. Okay, so these are some of the properties of the solids. Let's talk something about liquid also. Liquids, the substances in which the interparticular force of attraction the substances in which the interparticular force of attraction is low, or we can say that it is intermediate. Okay, it is intermediate to other matters, to other states, and has some interparticular space between them which is larger than solid but shorter than gases. Okay, are liquid. Okay, are liquid is called liquid. What are the properties of liquid? The liquids can flow due to presence of some interparticular particular spaces between them. They can take or change the shape according to the container in which they are stored. They have low melting and boiling point. Melting and boiling point. They have low densities. Okay, so these are some of the properties of the liquids. Let's move further and see the for gases. Gases, the substances in which the interparticular force of attraction is very low, and the space between the particles is very large are called gases. Okay, so the properties of gases, the they have no fixed shape and volume. They don't have any fixed shape or volume. They have very low melting and boiling point. They have about zero density. Zero density. Okay. So these are some of the properties for the gases. Now let's talk about the chemical classification of elements. Chemical classification of substances or matter. Okay, let's talk about the chemical classification of matter. So the matters can be chemically classified into two parts, that is one is elements and the another one is compounds. Okay, so the compounds can be further classified into two. Sorry. I have just skipped out one classification. The first classification will be pure substances and impure substances. This will be the first classification. Okay. After that, pure substances has been further classified into two parts, that is one is element and one is compound. Okay. Element and compounds. While the impure substance has been classified into mixture, and the mixture is further then classified into two parts, that is the first is your homogeneous mixture and the second one is heterogeneous mixture. Homogeneous mixture and the heterogeneous mixture. Okay, so these are the chemical classification of elements. So let's talk about first the impure substance, then we will move further. So the impure substance. The substances, in which two or more different substances collaborate with each other are called impure substances. Okay, if the substances are two or more, then it is natural that their uh, particles will also be different. Okay, so hence we can say that for different substances different particles are there. So here we can say that different particles are collaborating with each other, then that type of collaboration is termed as the impure substances. Okay, now for impure substances the type is mixture. Okay, so the mixture, water mixture, the combination of two or more substances in a fixed proportion. The combination of two or more substances in a fixed proportion is called mixture. Okay, it is being termed as the mixture. Now, the types of mixture are there. Okay, the first type of mixture is your homogeneous mixture. So the mixture that contains that contains components in which are indistinguishable distinguishable from their from our naked eyes from our naked eyes. Okay, are homogeneous mixture are homogeneous mixture. For example, salt plus water is a homogeneous mixture. Sugar plus water, it is also a homogeneous mixture. Okay, so these are some of the homogeneous mixture. Let's move further and see the next type of mixture, that is the heterogeneous mixture. Heterogeneous mixture, the mixture in which the components can be easily distinguished by each other are called heterogeneous mixture. Heterogeneous mixture. Okay, for example, sand plus water. Okay, uh, thinner or tarpin oil. Okay, it is also termed as thinner plus paint. What will happen if you leave the paint and add some tarpin oil in it? Then it becomes thin. Okay, becomes thin. But after when you leave it for undisturbed for some time, then what will happen? The thinner will uh, come upside and the paint will get settled downward. Okay, so this is also a type of mixture only, which is a heterogeneous mixture. Okay. So for the further classification, that is the elements classification and compound, we will have the next session. Okay. So for this particular session, I am ending the class here only. We will meet in the next session. Thank you for watching this.